Guys, we are starting a new unit. So congratulations on making it through Unit 4. Unit 4 was all about one variable statistic. So we were looking at just one set of data. Maybe it was shoe size or age or scores on a test, but we were only looking at one set of data. In this unit, we're going to look at what's called bivariate data, and it is all about two pieces of data, and we'll start doing frequency tables with that data. So first of all, we are looking at categorical data, and it's just a fancy way to say numbers that are collected in groups, okay, from some category. Now, bivariate data means you have two pieces of information. So maybe you're still looking at shoe size, but also looking at males versus females. Or maybe you're still looking at scores on a test, but you're breaking it down into what class period students are in. So you're looking at the same information, but from two different viewpoints. We're going to start with a two-way frequency table, and it's called two-way because you are looking at data in two different ways. Makes sense, right? So the first way that we are looking at data is we are looking at what type of soda or pop that people like. So the random survey, what kind of pop do people want to drink? Okay, so our first type of soda pop. Let's call it soda pop. The first piece of data is what type of soda pop a person would pick of these four categories. The second way we're looking at the data is what school the students are in. Students in high school or students in middle school. Okay, and we can look at it here. So think about what each of these numbers mean. This means there were 18 students in high school that chose Coke as their favorite. There were 6 students in middle school who chose Sprite as their favorite. And you can pick any of these boxes and do the same thing. So just follow what it lines up with. So 13 students in high school chose Mountain Dew as their favorite. Okay, this information in this box, those are called joint frequencies. If you've ever heard of jail called the joint, like, oh, you're in the joint, someone's in the joint, that's the easy way to remember this. So like these pieces are in jail, they're on the inside, so they're in the joint. Now you can easily imagine we could extend this chart by finding the totals. The totals that we talk about, those are called marginal frequencies. Easy way to remember that, they're kind of in the margins. So sometimes they're going to put these in boxes, but you can kind of think of that, hey, they're in the margins, they're out further away. So how would we find the total that goes here? Well, this total would represent, if you line it up with what its labels are, it would be the total of students that are in high school. So that would just be 18 plus 12 plus 4 plus 13, which is 47 total high school students that were surveyed. The next part that we would total would be all the middle school students. So 12, 10, 6, and 28 gives you 56. So we have the marginal frequency, the number of students that were surveyed. Likewise, we can find the Coke total. 18 and 12 is 30. Dr. Pepper, 12 and 10, 22. Sprite, 10, and Mountain Dew, 41. Okay, so these green numbers are the marginal frequency, and the numbers in the red box are joint frequency. Okay, so we have a two-way frequency table including totals. Let's look at another example. Which Wednesday after school activity are you involved in? So we went to a high school, we surveyed some students. Now look at your two pieces of data here. The first piece is what activity, and we've got 4 options. The second piece, the second way, is by gender, male or female. And then we are going to have our marginal frequencies in these like slightly gray boxes. as you can see, some pieces of data are missing. So the first thing you'll be asked to do is just fill in the whole chart. And it's kind of just fitting together a puzzle. So you want to look across your rows and down your columns and see, is there one row or one column that's only missing one piece of data? Well, in this column right here, I'm only missing this one. I know my total is 42, and I know I had 30 males. Well, this number and this number have to add together to give you 42. So 30 plus what is 42? In other words, 42 minus 30 has to be a 12 there. So we have to make sure our totals work out. Okay, continuing along with that thought process, like I could not fill in these blanks because I don't have enough data yet. However, the next column, I could fill in this one. I've got a total of 22. I know I already have 14 here, so 22 minus 14 must be 8. Not involved in anything, 50 and 30 for a total of 80. Okay, now I could go across this middle row. I could figure out my total number of females. 12 plus 26 plus 14 plus 30 is 82. That allows me to fill out this final column, 98 plus 82, for a total of 180. Okay, now I got to work across the rows. So in this top row, I have a total of 98, but I would need to subtract what I already know. I already have 30. I already have 8. So minus 8, and then minus the 50 that's already there. Means that there must be 10 people right here. And then 10 and 26 gives me a total of 36. And just to verify, let's make sure my bottom numbers really add up to 180. So 42 plus 36 plus 22 plus 80. Sure enough, it's 180. Okay, so this is just like putting a little puzzle together. All right, how many students are surveyed? So look at this data. How many students? They don't specify male or female. They don't specify in which club. So we want a complete grand total, and that would be 180. Always labeling units when able to. How many students are in math club? Again, it does not specify male versus female, so that means they want a total. So we would say 36 students. Yay, math. There you go, two-way frequency table. Okay, so here's that same table, same numbers filled in, and now we're going to talk about relative frequency. So this was just a frequency table. A relative frequency table takes the same data, but talks about it in terms related to the grand total. Okay, so it's relative, what's it relative to? To the grand total. Okay. So here's the same table, but now we're going to make it a relative frequency table. What you're going to have to do is take each of these numbers in our frequency table and divide it by the grand total. Okay, so that makes it relative to the grand total. 30 male basketball, but we would now have to divide that by 180. And if I do that, 30 divided by 180, we want these as decimals. So we're going to divide it in our calculators. Okay, so 30 divided by 180. Now, if you are not already familiar with how to make the fraction the decimal, let me show you. And by the way, some of you guys, when I'm talking about computer or calculator stuff in the videos, when you come over to my desk later, it's obvious that you don't know how to do stuff in your calculator. The stuff I'm showing you in your calculator is not optional. You need to know how to do it. So please make sure when I'm giving you steps or showing you how to do something in the calculator that you're learning that part as well. So if I just do 30 divided by 180, it spits out 1 divided by 6, 1/6. You can take that and change it to a fraction or to a decimal. Go to Menu, Number, Convert to Decimal, and it will take your answer, your 1/6, and make it into a decimal. So 0.16 repeating. Other ways to do it, when you do your original division, 30 divided by 180, you can hit Control, Enter, and it will give it to you. Okay, so two options there. What you can't do that I've seen some of you do, if you do it and you get your fraction, then I am having students hit Control Enter then, and you can't always do that. My calculator is set up that it'll work, but some calculators, what they do is then they divide by 180 again. Okay, so be careful with that. I would prefer one of the first two methods. All right, so that is approximately 0.17, we'll round it to. You are going to have to round these. They're not going to come out perfectly, most of them. Okay, so if I'm going down then, I would have 12 divided by the 180. So 12 from here and 180 because that is your grand total. 12 divided by 180, and I'm going to hit Control Enter to get the decimal, and that's 0.06 repeating, so I'll make it 0.07. My total there is 42, but it's relative frequency, so I have to divide it by 180. 42 divided by 180 gives me 0.23 repeating. Okay, rounded to 0.23. Okay, so for each one, you're taking the number in the block, dividing it by 180, and making it into a decimal. Go ahead and pause the video, and you guys fill out the rest of the chart. Okay, pause the video again as you check your answers. Make sure you've got everything correct. Also, I am using squiggly equal signs because squiggly equal signs mean approximately equal to versus exactly equal to. What percent of students surveyed are male? Okay, so we need to figure out percents now. These are decimals. How do you change a percent, or how do you change a decimal into a percent? If you have a given decimal and you want to go into a percent, you have to move the decimal point which way? Right, 2 spots. It's the same as multiply by 100. 100 because percent literally means per 100. So first of all, what box are we talking about? What percent of students surveyed are male? So here's my males. I don't want to know each individual club. I want to know the total percent that are surveyed male, that are surveyed. Well, I get 0.54, but to make it the percent, I move it over 2 spots and make it 54%. What percent of students surveyed are females in basketball? Well, here's my females. This time I don't want the total. I want females just in basketball. That's that block. Females, basketball. Make it into a percent, move it 2 spots over, so 0.07 becomes 7%. Okay, next up is, here's a new frequency table, a two-way frequency table, talking about different age groups and whether they share a computer or not. Now we're going to do conditional relative frequency. So first we started with just frequency tables, which is just the raw data right in there in the table. Then we went to relative frequency, and that just changes all of these into decimals, which are found by dividing your raw data by your total number. And in this case, your total would be 256, and you could check it adding it both ways. Both of these, this row and this column, should add up to 256. So now on to conditional relative frequency. So it's the idea of relative frequency, but based on a condition. So here is our condition. Given a student's age, find the conditional relative frequency the student shares a computer. So we're going to refill this table out, making it a conditional relative frequency table. The condition is the student's age. So what that means is we're still going to divide by a total, but it's not the grand total. It's the conditional total. What condition are we working on? We're working on the student's age. So that's going to be these totals. These totals down here are the totals of the age. Agree with that? It's the totals of 12 to 13-year-olds, total of 14 to 15, total of 16 to 17. So whatever they are giving you, that's the total you're going to divide by, okay, for a conditional relative frequency table. So we're still going to go with the 40 that's in this block originally, but we're going to divide it. So every time you have a relative frequency table, you're dividing. If it's just relative, you divide by the grand total. If it's conditional relative, you divide by the conditions total. And the conditions total for 12 to 13-year-olds is 50. So we divide by 50 there. So in our calculators, 40 divided by 50, some of you might know that off the top of your head, it's 0.8. Okay. The next one, there's 10 in that block originally. We're doing conditional based on the student's age, so we would again divide it by 50. 10 divided by 50 is 0.2. Then your total is 50, but we're dividing it by that total, so that would just be 1. So all of these totals down here, those should all be 1s, because each time you're dividing by the total. So there were 72 in that block, but I'm dividing it by 72. 78 divided by 78, 56 divided by 56. Okay. All right, let me do one more column with you. So this one is 47, but we're given their age, so that means we're dividing by the age of that bracket total, so that would be 72. So 47 divided by the 72. And that gives us 0.65. I'm going to go 3 decimals, actually. 0.653. Just gives us, the more numbers we include, the more accurate it is. Okay, I want you guys to try and fill out the rest of this. Make sure you get the right total that you're dividing by. Pause the video. Okay, pause the video again and check your numbers against mine. Suppose you select a person at random. If the person is 15 years old, do you think that they share a computer? So basically you are given that the student is 15 years old. So we are looking at this data. Do you think they share a computer? Well, chances are, yes, they do. And the reason for that is, if you make these into percents, 65.3% share a computer. Okay, which is more than the 34.7 that said no. All right. Now, here's where it gets a little tricky. You can do conditional relative frequency 2 ways within a single 2-way chart. And that is because it depends on what you're given. So say instead of given a student's age, what if we were given whether or not they share a computer? So given that a student shares a computer, find the conditional relative frequency. Now in this case, we're going to be dividing by a different total. On this one, we divided by the age totals, right? Right here, because we were given their age. But now we're given whether or not they share a computer. So instead, we're going to have to divide by the total in these columns, or in this column, okay? So for this one would still be 40. It's always the raw data, but what are we dividing by? Let me make this bigger. We are dividing by the total that do share the computer, which would be 151. So everything in this top row is going to be divided by 151. When we get to the bottom, the no's, we'll have 10, but this time we're not dividing by 151, we're dividing by the total that said no. So the whole key here, guys, is whatever you are given, that's the one you divide by. Okay? Pause the video, fill out the entire, what's this thing called? Table. There you go. Okay, check your answers with my answers and see if you get the same thing. Suppose you select a person at random. If the student shares a computer, how likely are they to be 16 to 17 years old? So here's your given. We are given that they share a computer. So that means we are looking at conditional relative frequency based on this chart, not this one. Okay, it's all about what you're given. Notice that your numbers are different in these two charts, very different. because it's all divided. They're all divided by different numbers. If you are given that the student shares a computer, how likely are they to be 16 to 17 years old? So given that they do share a computer and they're 16 to 17, that's this box that I already outlined. And that would be, you could say 0.278 or 27.8%. So you're going to be asked to answer lots of different questions. And you won't necessarily have to fill out all these charts every single time. But going back to just our raw data up here, let's go to one of the other ones. Let's go to this one. So they might ask a question like, good morning. Hi, Lisa. Yes. Okay.
And if you need somebody for...
I haven't asked, well, Erica came to me, but I haven't asked anybody else, so.
Just giving you a heads up.
Okay.
I could, but I don't want to.
Yeah, no, that's fine. Don't do it then.
What's that?
I'm recording a video. It's my microphone.
Right.
Do a little karaoke. Thank you. Oh shoot, I didn't know that was still recording. Sorry. Anyway, so the two questions. Given a student is male, what percent are in band? So you're given that they're male. So that's the total you're going to work with. So total male students would be 98. What percent are in band? That would be 8. So like I'm saying, you're not necessarily going to have to fill out the chart every time, but you're going to have to be able to find the same data that we had in those charts. So 8 divided by 98 gives me 0.082. So what percent is that? That would be 8.2%. Now, kind of compare that to this question. Given a student is in band, so that is our total. Okay, so now you're given that the student is in band, so we're going with 22 as the total. What percent are male? It's still 8. It's still 8. We're still working in the same box, but again, it's all about which one are you dividing by. And whatever you're dividing by, that is what they're giving you. So the given is what needs to be your denominator. 8 divided by 22 is 0.364. So that would be 36.4%. So you can see how different these answers are. It is so important that you pay attention to what the given part is. That's the denominator. Okay, here you go.